Hi everyone, welcome back to our physics lessons. Today we are going to solve a problem related to gravitational potential energy. This is a fundamental concept in physics, especially when dealing with objects moving in a gravitational field like the Earth. Let's dive into the problem and break it down step by step. Here's the problem. A crate has a mass of 18 kilograms. A crane lifts the crate from a height of 3 meters above the ground to a height of 18 meters above the ground. We need to calculate the increase in gravitational potential energy of the crate. Here's the problem. So, before we jump into the calculation, let's quickly review the key concept here: gravitational potential energy. Gravitational potential energy is the energy an object possesses due to disposition in a gravitational potential energy is the energy an object possesses due to its position in a gravitational field. The higher an object is lifted, the more potential energy it gains. The formula to calculate gravitational potential energy is U equal to m times g times h. U is the gravitational potential energy, m is the mass of object, g is the acceleration due to the gravity, which is approximately 9.8 meter per second square on Earth. H is the height above the reference point, usually the ground. Let's start by identifying the value given in the problem. Mass of the crate is 80 kilograms. The initial height of the crate is 3 meters and the final height of the crate is 18 meters. So, acceleration due to gravity is, g, is 9.8 meter per second square. So, since we are asked to find the increasing gravitational potential energy, we first need to determine the change in height, delta H. This is simply the difference between the final height and the initial height. In this problem, 18 minus 3 equal to 15 meters. So the crate is lifted by 15 meters. Now we can use the formula for gravitational potential energy. However, since we are calculating the increase in potential energy, we'll use the change in height, delta H, instead of the absolute height. The formula becomes delta U equal m times g times delta H. Let's plug in the values. 18 times 9.8 times 15, it's equal to 11,760 joules. So the increase in gravitational potential energy is equal to this number. So what does this mean? It means that lifting the crate 15 meters higher, the crane has done work to increase the crate's potential energy by 11,760 joules. This energy is now stored in the crates due to its new position in the gravitational field. And that's it. We'll successfully calculate the increasing gravitational potential energy for the crate. Remember, gravitational potential energy is all about the object's mass, the height it's lifted, and the strength of gravity. If you found this helpful, don't forget to like, share, and subscribe for more physics lessons. Thanks for watching, and I'll see you in the next video. Let's master physics.